Yes, good afternoon, everyone. So I'm going to talk about sort of a new venture, new project at CADIA, and this is sort of a start of something that I consider something of a great opportunity to work together with a lot of different research groups around the world. And this is under the title of Ambient Assisted Living. Now, we have to face the facts. We are growing old. And in fact, Europe's elderly population is constantly growing. This is a challenge in many ways. There is an increasing number of older people that are living alone. And we know that for this population, daily living can be a challenge. We're trying to meet this challenge. We're trying to make the lives of the elderly people better and safer all the time. And we do this primarily with human resources. We have basically people going out, visiting the elderly in their homes, meeting them regularly, setting up different centers where we can cater to different needs, setting up special facilities where the elderly population can move into and get basically a 24/7 type of assistance. However, the human resources and these facilities are just pretty, well, they're not available everywhere. And in many cases, the older population is not terribly thrilled about moving into one of these homes. They would like to stay independent as much as possible. Now, technology has been introduced to make this better, to improve the situation, to allow people to stay independent longer at home. For example, we are all familiar with the medical emergency buttons, where an elderly person can simply tap a button and then immediately get into touch with a medical service with a moment's notice. And where someone is analyzing the situation, someone is sent home at a very short notice. This is something that already has created a sense of kind of safety and comfort in the home. We have set up different communication technologies. For example, the ways of connecting the elderly people that are living alone with their families through some interfaces that are actually easier to operate than a desktop computer. Even things like iPads have made this a bit more easily done or easily accessible through people that don't have computer literacy necessarily. You've probably also seen these kind of picture frames that download pictures automatically into them and display the family photos in rotation in the living room. It's a subtle thing, but it keeps people connected a little bit more with their families in other places. Mobility solutions of all sorts, I mean, basically getting from one place to another becomes a real challenge in old age, and everything from better, chairs, wheelchairs perhaps, motorized wheelchairs with things that get you up and down stairs and things like that. These are all solutions to the problem of mobility that allows you to stay at home for longer. All sorts of appliances, when you think about it, the living environment is full of electronic equipment. Maybe we can design this equipment to be a little bit more safe. Maybe the equipment itself can kind of know something about what's happening to it. For example, I mean, a stove could kind of figure out if it's being used or not. And if it's not being used, well, let's just turn it off. Let's make sure that nothing is staying on if it's not being used. You probably also got into situations where this type of, well, kind of dumb intelligence in some sense is not that terribly helpful. Have you actually, I don't know if you've used the toilets here in this building? Have you been sitting on the toilet here at Reykjavik University and the light goes off? Excellent automation. I mean, the light is really thinking, well, there's probably no one in here, I'll just turn it off. Why didn't the light speak to the toilet and ask the toilet, is someone using you right now in this room? Certainly, unfortunately, there was no communication between these different appliances. There was no feeling for what we call the context of activity taking place in that environment. Even though some individual systems can be made safer, we're still tackling with a problem of much more general environmental intelligence. And this type of intelligence that we're talking about, this type of system that looks for the whole, at the whole problem, is something that has been termed ambient assisted living. And the definition of this technology or system is, this includes methods, concepts, systems, devices, as well as services that are providing unobtrusive support for daily life based on context and the situation of the assisted person. So we are already thinking about a whole very complex system where hopefully everything is talking to each other and figuring out how to best assist the person from the perspective of that person, from the perspective of the goals of that person. Not the building deciding, okay, I want this done. No, the building has to understand what does the person want, what is the person trying to achieve, and let's help it. And notice also unobtrusive. You'll probably sometimes run into systems that kind of push something on it because they think that's what you want, and they become terribly obtrusive. They get in your way. And so there's a challenge here, which is to try to stay a little bit out of the way of the person as well. Now, this is an incredibly hard problem. If you want to solve this, you really have to come up with some incredible, ingenious solutions. And we believe that the natural marriage here is this ambient assisted living and artificial intelligence. These two things seem to coexist pretty well. If you think about it, the ambient assisted living system will have to do these three things to be effective, to meet the goals. One is to make sense of the user's world, make sense of the world that the person is living in. You know, how does the entire apartment kind of work for that user, and what is going on in that world? And notice it's not just about identifying individual objects and how they're doing, but really the whole. Now, this system would have to understand the behavior of the person, and not just the behavior, but hopefully also the goals. What is the person trying to achieve at any given moment? And then finally, trying to somehow unobtrusively interact and assist that person in achieving those goals. These are all terms that are actually, we keep talking about in artificial intelligence. We want our artificial agents to be able to do exactly these things when they are going about their business in some kind of an environment. So the AI methods seem to be quite appropriate for addressing these systems. And this is a start of a collaboration between the AI lab, CADIA, basically here at Reykjavik University, and Camerino University in Italy. In Camerino, there is a group that is called the Complex Systems Group, and they are precisely dealing with systems of this complexity all the time. And we here at the CADIA, we deal with agents and reactive systems and planning systems. And the goal is more or less to create almost like sort of like the shadow world that they were talking about here earlier. We were starting to see a glimpse of sort of the parallel universe that is completely digital. Imagine if that home would have a parallel home. It's basically like that home and its inhabitants are basically also existing in a computer simulation simultaneously. And that simulation will have to pick up everything that's happening in the real world, replicate it in the synthetic or computational world, and in that computational world, it can do all sorts of reasoning, planning, and simulation to figure out where are things going, what's happening, and maybe there's certain times where we have to step in and help. I admit that this image here is not from our project. This is actually a computer game called Frozen Synapse, where in the computer game you actually get to look into the future for your character and make decisions based on what the simulation of the future gives you back. And I think it's a very kind of a nice sort of metaphor for what we are trying to achieve as well. Well, this is sort of just a brief introduction here to this project that is ongoing. And then basically I want to conclude with an advertisement for master's thesis defenses that are going to take place in the next couple of weeks. But these are actually students from Camerino that came to CADIA to do their master's thesis research project, and as a part of a double degree program that we have with Camerino. And each student was taking on one of these three main problems that we are addressing, sort of as an exploration into this bigger question. The first one being having the system become aware of the overall context of what's going on in the environment, or what we call the situational or context awareness. Once you have a picture of what is happening in the world, then maybe you also want to understand a little bit about, so what are the goals of the individuals at that moment? Can you detect somehow what the activity is that the person is trying to pursue at any given moment, given all this information? And then once you have understood what the person is trying to achieve, is there some way of stepping in if things are going bad? And I'm not going to go into a lot of technical detail. You can speak to the students here, and maybe also go to the defenses. But briefly, the first project that is done by David Sorrentino is integrating semantic networks and object-oriented model to represent and manage context. And in very short, he has built a Python tool, Python being a programming language that has been widely used, in fact, to build these types of applications, where you basically program a system in Python and your connections with different types of sensors in the environment. And from all of that Python code, basically is generated automatically what is called a semantic network. And this is kind of a nice abstracted structure that allows you to query knowledge about the state of the world and the environment. And this is and that knowledge is in a standard format called RDF, and you use a special open query format to ask the knowledge base about things like, for example, you could ask this knowledge base, is there anyone in the house? Or is there anyone on the toilet? Or things like that, and it will reply to you using this kind of standard notation. And you're able to do some reasoning on top of that as well. Another project done by Francesco Lilli is the observation of multiple features for recognition of daily activities. So this is actually looking at how we can determine what the goal of that person is, just by observing a few streams of information. Let's imagine that you put in every object some kind of a detector that knows if you're holding it or if you're not holding it. It's a very simple device to embed in different pieces. You might also put something on the floor that tells you if you're standing on it or not standing on it, so you know approximately where the person is standing. And you also know maybe whether a person has turned something on or off. Different streams of information like this can come into a system, and based on this, can the system then determine, is the person cooking? Is the person maybe just resting? Is the person going to use the bathroom, and so on? So Francesco has been looking at all of this. He's been doing real-world data collection. So he's actually using real activities, and then using hidden Markov models and different combinations of different information to see what best helps you recognize what the person is doing. And I probably shouldn't steal his thunder because he's going to present his work in a couple of weeks. But he's sort of been finding out that if you know something about what is being turned on and where the user is, you get a lot of information about what the activity is that the person is engaged in at that moment. The last one is an early warning system for ambient assisted living done by Andrea Monacci. And interestingly, he's kind of modeling this apartment with the person in it kind of in a similar way as you would model a game. And you will hear more about the general game playing from Yngvi in a moment, I think. So it's a game with certain rules that describe the logics of how things work in the environment. And there's a reward system. There's a rewards and penalties for things that could go wrong or could go well. So, there was a certain reward of actually getting your food to your mouth. If that's your goal, to eat, well, you certainly would get penalized for putting something on fire. And so you can describe the logics of how this might happen in this game description language. And then you kind of play the game along with the user as the person is going about its business. In the background, the computer is playing the game. And then the computer is looking into the future, because the computer can do that. It's a game that completely exists in a computational world. And by playing the game into the future, the computer might realize that there's a dangerous situation ahead, and therefore warn the person or even suggest better actions to take at that moment. Okay, so you should stay tuned, and these defenses are going to take place from the 29th to 31st of May here at Reykjavik University. You're welcome to attend, and also if you're interested in this type of problems and projects, please get in touch, and we'd love to set up some kind of collaboration. Thank you.
We have time for one or two questions.
No? All right.
If not, I have a question.
Yeah.
How do you intend to combine the results of these theses?
Yes. So to build the ultimate system and everything is talking to each other, that will, of course, have to happen at some point. What we are doing is, of course, we're trying as much as possible to use well-defined interfaces and well-defined tools. One of the things, is to use open standards to represent things, like the general game playing language, like the query language, and all of these things. These ultimately can all coexist in some kind of a larger system. And we can use third-party tools that also operate on these things. So, in theory, we could be collaborating with the rest of the world as long as we're all using these well-defined languages. Yeah. So the question or comment is that there's a very interesting aspect to all of this, which is to improve communications between the elderly and the rest of the world or the rest of the family. And there are all kinds of ways to kind of break down, in fact, a little bit what we saw in the shadows just now, is sort of break down the physical walls and create the virtual portals into other homes. So you could ultimately conjoin basically apartments in different locations of the world. The grandmother is living in one half of the apartment, the rest of the family living in the other half of the apartment. But they are physically in different places. Things like this is something I would like to experiment with as well. And artificial intelligence will play a role in that as well. I'm going to give the microphone to Angelo. Yeah. And I just want to say Angelo is my PhD student who is actually working on something that might also connect into this very project as well.